In the RC circuit, you will build an RC circuit with a resistor and a capacitor, somewhat like this. So this is a 10 kilo ohm resistor, this is a 47 microfarad capacitor. And we're using this board because we have these switches that we put in so that when we press the left switch, then the capacitor will charge. When we press the right switch, the capacitor will discharge. And the rest of the wires are so that the circuits are completed so that the capacitor will charge when we press the left button and discharge when we press the right button. So in the first part, you're asked to connect Logger Pro from the left of the capacitor, so between the capacitor and the resistor, and to here, and then play with these two push buttons and see what signal you get in Logger Pro. You're supposed to get sawtooth-like signal. Then you want to charge the capacitor. So first make sure that it's completely discharged before you press the collect button in Logger Pro. So then when you're pressing the collect button, then you will see that the capacitor will be charged. Some of these switches can be finicky, so you don't get a nice smooth signal all the time. But if you do the experiment a few times, you should get some pretty nice curves. So once you charge the capacitor, then you can save that file and then discharge the capacitor by pressing this other button. And then we want to measure the voltage across the resistor. So right now it's across the capacitor. We move these two Logger Pro terminals across the resistor, and we do the same thing. We charge the capacitor and then we discharge it. So again, we press this button to charge the capacitor and measure the voltage across the resistor, and then we press this button to discharge the capacitor and measure the voltage across the resistor. And of course, the voltage that we have is a maximum of 3 volts from our 2D cells here. So at any point in time when you're adding the voltage across the resistor and across the capacitor, when the capacitor is charging, you should get a maximum of 3 volts. And when you add the voltage across the resistor and across the capacitor, when they're discharging, the sum of those should be 0 because there is no battery in that circuit anymore. Okay, so this is one part of the RC circuit experiment. In the next part, you will be asked to build a low-pass filter. So a low-pass filter contains a resistor and a capacitor, and we are going to use a function generator and an oscilloscope. The function generator will be the function that we are inputting into our circuit, and the oscilloscope will read the output. So first thing you're asked is to place the hot across the function generator to read the function generator's output. So now we have both red cables and black cables in the same spot across the entire RC circuit. So looking at the function generator on the left, I already set up the frequency to be 500 Hertz and the voltage to be 5 volts peak to peak. So that's for calibrating purposes, and then when we look at the oscilloscope, we see that we're reading out the exact same thing. Now I'm going to move the scope probe between the capacitor and the resistor, and let's see if this, there we go. Okay, here we go. And you probably noticed that the oscilloscope's signal changed. So now that we're only measuring the output across the capacitor, the signal on the oscilloscope changed. It's no longer 5 volts peak to peak. So the next step in the lab is to change the frequency on the function generator to values that you can read in the lab manual. It's like 10, 20, 50 Hertz, all the way up to 10,000 Hertz. And read out from the oscilloscope the peak-to-peak voltage of the signal. That will show you how what a low-pass filter will do.